Hello everybody and welcome back to Algebra. Today, as I said, we're moving on from graphing and we're going to be doing something a little bit different. Now, when on occasion you might be asked to find what the values of two variables might be, and to do that they're going to give you two equations to help you figure that out. Now what this is called is a system of equations. What it means is both equations are in play and the letters, right, the variables are going to be the same in both. So that means the x's are the same and the y's are the same. Now there are two different ways to solve these equations, and we're going to go through both methods, and we're just going to start with some nice simple examples here. Okay. Now the first kind of way to solve these systems of equations is called substitution. Now what you're going to do here is you're going to solve one of the equations for one of the variables. So you're going to isolate one of them, and then you're going to plug that value in the equation that you didn't solve for already. So for instance, in this one, we've got 4x plus 2y equals 6, and x plus y equals 10. So what we're going to do is, because this equation is easier, we're going to solve it for either x or y, it doesn't really matter in this case, and then we're going to take that and we're going to plug it into the other equation so that we only have one variable remaining. Let's show how that's going to work. So in this second equation here, we're going to solve for y, just because we've been doing that for graphing, so might as well stick with it, right? So we're going to move x over, and we're going to get negative x plus 10 is equal to y. Now we can take negative x plus 10 and we can put it into this first equation for the value of y, like so. Now we have an equation with just x's in it, and so we can actually solve for x. We're going to do this, and then once we have the x value, we can solve for y. Pretty easy. So let's do that. First things first, we'll need to distribute. Oops, making mistakes already. So we're going to get 2x is equal to negative 14, so x is equal to negative 7. Awesome. So we now have one value in our system of equations. We know that x is negative 7. So we're going to take negative 7 and we're going to plug it into this equation right here because it's the easiest one to solve. And so we're going to get negative 7 plus y is equal to 10, and in that instance then y would be equal to 17. So now we know that y is 17 and x is negative 7. We've solved that system of equations. We know what the value for x and what the value for y is. That is the substitution method. Now let's do a different example for the other method. All right, here's our other example. Now the other method to solve a system of equations is called the elimination method. And we go a little bit differently. You're not going to be really solving at the beginning. You're going to be doing some manipulating of the equation to make it match what you want it to do. In this case here, what we're going to do is we're going to treat this like a big addition or subtraction problem. We're going to put a line underneath like this, and we're going to put a minus here. We want to make sure we can eliminate a variable. How we're going to do that is we're going to multiply one of the equations by a coefficient. So in this case, we're going to multiply the bottom one, just because of the way I have it set up, and we're going to multiply it by negative 5. By doing this, we're going to have the x's be opposites of each other, and they can cancel out. So if we do this, we're going to get negative 5x minus 30y equal to negative 60. So now if we do the elimination, we see that 5x minus 5x, that's 0, they go away. 2 minus 30 is negative 28. And then 6 minus 60 is negative 66. So, hold on, 6 minus 60 is not negative 66. My apologies. 54, there we go. Sometimes it takes a few tries. All right. So now we can solve for y. Now this one's going to give us a fraction, and that is the unfortunate part of coming up with these on the fly like I did here. So we'll reduce that real quick, just make it a little bit easier for us. So let's see, we can divide by 4. So that's going to be no, we can't divide by 4 for 54, or can we? We cannot. We can divide by 2. 2, that's going to be 28. No, it can't be 28, can it? Math is hard sometimes. Hard to do math in your head. Let's try it this way. 2 times 2 is 4. Aha, I was 1 off. 7. All right, 27 over, this would be 14. And that is unreducible. Okay, so 27/14 is y, odd kind of number. And you're going to get these sometimes with these sort of equations. And now we can use this y value to solve for x. So we've got one of our original equations here, x plus 6y equals 12. Oops, sorry. And we're going to plug in our y value. So we're going to get x plus 6 times 27 14ths. And then you can go on to solve x. And so on. I'm not going to do the problem here. As you can see, I really struggled with 54 divided by 2. So best to leave that for maybe a calculator. The point being is, though, you can get a value for x and a value for y by doing the elimination method as well. So these are relatively simple examples here, but they do illustrate the point that if you're given 2 equations and you say that they're a system of equations, you have 2 different methodologies to solve them. Now, this has only been one example, and I understand that, so don't worry, there are going to be more videos where I go over more examples. This is a big part of the back half of algebra, doing these systems of equations. They're going to ask you to use a lot of the skills you've learned in the earlier half of your class to do something a little bit more complex, which would be this. Don't worry, though, if your skills are solid, you're going to be fine. In the next video, we'll do some more examples of both substitution and elimination, and we'll get you up to speed. Thanks for watching, and we'll see you next time on Algebra.